Hello everyone, this is challenging math problem number 7. We're going to be solving a trigonometric equation in two variables. So we have the following equation. Before I go into the solution, you can go ahead and pause the video at this point if you want to try the problem yourself first. Okay, here we go. So we have some expressions in fourth power, and so I'm going to consider some inequalities here. If you take a look at the sum of fourth powers, we do know that since a to the fourth power plus b to the fourth power minus 2a squared b squared is greater or equal to 0, I can just go ahead and apply that here, meaning that tangent to the fourth power x minus 2 tangent squared x tangent squared y plus tangent to the fourth power y. This expression is actually equal to tangent squared x minus tangent squared y quantity squared. So it's always going to be non-negative, right? So I can say that this is going to be greater or equal to 0, meaning that I have tangent to the fourth power of x plus tangent to the fourth power of y greater or equal to 2 tangent squared x tangent squared y. Okay, now how do we use that expression in the equation? We're going to find out in a little bit. Now I do need something that I can use to compare tangent squared x tangent squared y plus cotangent squared x cotangent squared y, and that actually comes from the fact that they're reciprocals. So I can go ahead and write this as well. I can basically say that tangent squared x tangent squared x tangent squared y plus cotangent squared x cotangent squared y. Basically, I'm just writing something like a plus 1 over a, which we also know that is greater than or equal to 2. Okay? So we're basically adding two positive reciprocals. They can only be equal if tangent squared x tangent squared y is equal to 1. Then the sum is going to equal 2. Okay? So now we're going to put these two together. Basically, if in this equation, if you go ahead and add this quantity, 2 cotangent squared x cotangent squared y to both sides, we're going to be getting the following: tangent to the fourth power x plus tangent to the fourth power y plus 2 cotangent squared x cotangent squared y. So basically what I'm doing is I'm adding this expression to both sides. So on the right hand side, I'm going to be having 2 tangent squared x tangent squared y plus 2 cotangent squared x cotangent squared y. Okay? And as you know, this expression is just this one multiplied by 2. So that means that our whole expression is basically going to be greater than or equal to 4. Okay? So from here we get that tangent to the fourth power x plus tangent to the fourth power y plus 2 cotangent squared x cotangent squared y is greater than or equal to 4, which is the left-hand side of our equation. Okay? And we have this expression on the right-hand side, so we're going to take a look at that. As you know, 3 plus sine squared x plus y, since sine x plus y is going to be between -1 and 1, its square is going to be between 0 and 1 because it can't be negative, obviously. And when you add 3, we're going to find out that this expression is actually going to be less than or equal to 4 because the maximum sine squared x plus y can be is 1. Now, what does this tell you now? We have an equation. The left-hand side needs to be, this is the left-hand side, by the way, and this is the right-hand side. So the left-hand side needs to be greater than or equal to 4. The right-hand side needs to be less than or equal to 4, meaning that in order for both of these to happen at the same time, both sides have to equal 4. So we do actually get a really nice equation from here. Therefore, the equalities all need to be satisfied, meaning that we have tangent squared x equals tangent squared y, arising from the fact that our assumption was this, right, squared is greater or equal to 0. But in order for equality to occur, this needs to equal 0, meaning that tangent squared x equals tangent squared y. And then for the second expression, for the sum of reciprocals, And we already, I think, said that here, that tangent squared x, tangent squared y needs to equal 1 in order for the sum to equal 2, because 1 plus 1 equals 2. Okay, otherwise it's going to be greater than 2. So the second part gives us tangent squared x times tangent squared y is equal to 1. And of course, we do know that sine squared x plus y is less than or equal to 1, which gave us the right-hand side as well. So, and since this is actually not an inequality, this should be an equation, because if the other sides are going to satisfy the equation, then this also needs to equal 1. Okay, so from the first two equations, what are we going to be getting? We can use substitution here. So we should be getting tangent squared x and tangent squared y are both equal to 1, because they're equal and their product is equal to 1, and they're non-negative expressions, so they can't be negative 1. So this is what we get from the first two equations, which means that tangent x can be plus minus 1 and tangent y is plus minus 1. Since their squares are 1, they can be plus minus 1. Okay? And all of these combinations of signs, there are 4 different combinations, the plus minus, the minus plus, and so on and so forth. They're all possible. Therefore, we can go ahead and write down the solution as x equals. So when is going to be the tangent? Tangent is going to equal positive 1 or negative 1. It's basically going to happen at multiples of pi over 4. But only is going to happen at the odd multiple. So we can go ahead and write it as 2k plus 1, where k is an integer, multiplied by pi over 4. And pretty much the same thing for y, but let's use a different variable. Let's say 2n plus 1 as an odd multiple of pi over 4. So here k and n are arbitrary integers. They can be any integer basically. Now what we need to do is we do need to choose among these angles the ones that satisfy the third equation. So what we're going to do here is, this one, okay? So what we need to do is we're going to go ahead and substitute these values into the third equation, and then make sure that the third one is also satisfied, because we have a system of equations with 3 equations. So let's go ahead and use that. Sine squared x plus y, which is supposed to equal, if we go ahead and substitute, for x we're going to substitute this one, and for y we're going to use this one. So their sum is going to be an even number, which we can divide by 2, and that's going to give us, after cos cancelling, pi over 2 multiplied by k plus n plus 1. Okay, so that's the value of x plus y after simplifications. And as you know, if k plus n plus 1 is an even number, then you're going to be dealing with even multiples of pi over 2, which is like pi or 3 pi and so on and so forth. So what's going to happen at, pi, 2 pi, and so on and so forth. So what's going to happen at those points? So we can write it actually as a piecewise function. So this is going to equal 0 if k plus n plus 1 is even. Okay, and it's going to equal 1 if k plus n plus 1 is odd. Okay, so from here it basically follows that we're going to be choosing k and n such that k plus n is odd here, and then k plus n is even here. Okay, so how do we do that? Well, we can just go ahead and do the following. First of all, if you're going to assume that k plus n is even, okay, if k plus n is even, that means k plus n can be set equal to something like 2m. From here, if we solve for n, we're going to get 2m minus k. M, n, and k are all integers here. So basically, the solutions of this given equation are going to be pairs of the form x equals 2k plus 1 times pi over 4, and then y equals 4m minus 2k plus 1 multiplied by pi over 4. Okay? And we can just go ahead and proceed. All right. So we can also go ahead and proceed in a different way. I'm just going to leave the rest to the audience here. Thank you for watching and see you in the next video. Have a good one. Bye-bye.